Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. So this is question 3652, best time to buy and sell stock using strategy. So basically, you're given these two arrays and you want to make at most one modification to strategy, which is basically taking a portion of strategy. Let's use this example here and copy it. If k is 2, then basically we're going to modify at most one subarray of size 2 to become basically 0 and 1, right? Or we can select the subarray 0, 1 and also turn that into 0, 1, which is going to be the same thing in this case. So it's just this subarray that makes a difference. And we're going to do that for any size of k. And we're going to try to make the biggest amount we can by multiplying the same values in the same positions in both arrays, and then calculate the biggest value we can get. So let's go ahead and do that. Let's declare an answer and return it at the end. And first, let's go ahead and actually make some observations. So if you set this to 0, if you set the first half to 0 and the second half to 1, which it says here, then if you multiply anything by 0, then it's not going to be adding up to anything, right? Anything times 0 is just 0. So we can just ignore the first half right away. And the second half is just 1. Anything times 1 is just itself. So why not just sum up the second half instead if we're going to change it, right? So that makes our life a lot easier if you notice this. So let's go ahead and create a prefix array. And that's for prices because that's what we're going to be summing up. Strategy is going to be changed. So basically now what we can do is go ahead and try to modify, or first let's go ahead and just get every single subarray of size k and calculate the impact without any modifications. So because it says at most one modification, you might not even have to do one anyways. So let's go ahead and calculate that. And let's call this current. And we're going to add prices of I times strategy of I. Okay, cool. So then we're going to maximize answer and current. So that's just the case where we have no changes, right? So no modifications. And then now we're going to actually go ahead and do the modification. So this is where it gets interesting because we're going to try to select the subarray of size k and then modify it, right? So let's go ahead and first calculate. So if, for example, if we're on k here, then we also have to add everything that came before it. So the entire subarray after being impacted by that size k change, basically. So you still have to add the rest of the elements before the k and then after the k if there are elements after the k. So let's go ahead and declare before and after to basically make our life a little bit easier, because when we go over every subarray of size k, which we're doing here, let's call this left and right, is going to be I and I plus k. So basically the start of the window and the end of the window. This is, you can think of it like a fixed size sliding window. And we're just going to add prices of I times strategy of I. So anything that's accumulated before is going to be added to it, right? So because before is always just going to go from here to here to here, it's always going to increase, other than it's always just going to go left to right because these might be negatives. It might offset it, but you guys get the point. We're just going from left to right. So it's very linear. And the same thing with after. So for example, if we're using a subarray of size k, and let's say this is 1, 2, 3, 4, 5, 6, and k is 2. So if we're looking at this subarray, then we have to calculate everything before, the multiplication, the sum of those multiplied pairs, and then the same after. So if we're looking at this subarray. So before we worry about the current subarray, which is going to be what I just told you. So the after is just going to be basically k to the n. So our first window is at least going to be of size k. So we're going to start 0, 1, 2 to the end, because that's going to be the sum of everything after, right? So um, for I in range k to length of prices, let's call this after. Let's put it here actually. So for I in range k to length of prices, so we're going to add, or after we're going to add prices of I times strategy of I. And then here we're just going to subtract prices I plus k minus strategy of, we can even just call this right? And then we call this left because that's going to be the start of the window and right is the end of the window. And let's make sure if right is less than length of prices, then we can do this, right? Because if we're at the last window, there is no after sum to add. Cool. So at the end of every iteration, we're going to maximize the answer with the total, which is just going to be the sum of the pairs before and mid and after. Let's call this mid. And so this is where it gets interesting because we have the size of this window, and let's say we're using this subarray. So if we're looking at 3 and 4 and 5, basically, again, everything before it is going to be 0, right? So k divided by 2 is 0. So let's call this half is going to be right minus left divided by 2. And let's go ahead and print left and right, and let's print half just to make sure we're on the right track. Okay, so you can see this is not correct because for the subarray of, let's say, 1 to 3, the half is not here, the half is here. So the actual left is we're going to print is going to be left plus half. Because half is just the size of the subarray divided by 2, we still have to add whatever was before. So you can see that's actually the midpoint of this subarray. So now let's call this left half is left plus half. And as I told you, this is where that whole insight comes from. Because if anything is, so for example, if we're looking at an even size subarray, so let's leave the odd size subarray for now, just to make it easier to visualize. So even some subarrays, if this is going to be 0, and then this is going to be 1, we don't have to add anything for this, right? Because anything times 0, if you're cross multiplying pairs, anything times 0, if this is the part of that strategy, right? This is strategy, is going to be nothing. It's going to contribute nothing. So we can just ignore this half. And then this is just the sum of this. Why? Because anything times 1 is just itself, right? So that's kind of the insight that I came up with here. So if you know that, then it becomes, excuse me, a lot easier because we can basically just say if, first of all, if, well, left half is never going to be at 0 because you're always adding something, right? So in that case, mid should always just be P of right minus P of left half, right? The sum of this subarray, because we're adding it. So we're trying to see if that's going to be result in a better answer than whatever we calculated here originally, right? So then at that point, let's go ahead and try this because you might have some index out of bounds errors or some other things. If it doesn't work, then let's just set mid to 0, right? Okay, so let's run this. Okay, it doesn't work. And before, let's do that here because this is afterwards. Here, because that is supposed to be where it's coming from. Let's see why we're having some issues. And k divided by 2, I might not be calculating those odds correctly. Okay, and let's do a minus 1. Some weird edge cases here. Let's print So this is fine for now. So yeah, let's go ahead and print some of, let's go ahead and just print the prices of left half to right. Let's do that. Let's print prices of left half to right. Yep, so, okay, so, again, here, let's take this example. We're looking for 10, right? So 1, 3. So if 2 is here, then we're actually supposed to be, so 1 to 3 is not correct. 0 and 2 are the index bounds. So what we want to do is actually this, right? Because right is supposed to be down 1. Okay, that looks a little bit better. And this is a problem because I accidentally defined this as 0 instead of negative infinity, because we can't have negative values in this problem, right? So let's run this. Okay, submit it. Okay, not correct. Okay, let's step back and see if, I don't think that is the problem. Let's use this test case. Let's print left and right again, and let's print left half minus 1 and right just to see. 7 and 9. So which one are we looking for? Well, let's actually also print P. So if we're looking for 9, then it seems to just be this times this plus this times this. That's not right. So this is the original. That's fine. Let's call this original with no mod. And then before and after was before even calculated. Yes, because before is left, right. Let's just do this brute force. Maybe I got part of this wrong. Let's call this, and let's just go ahead and do this. Comment this out. Let's call this after is 0 for j in range I plus k to length of prices. After plus equals to, again, this is not the modified section, right? Prices of j times strategy of j. Okay, cool. So might have made a mistake somewhere there. That's fine. With this, okay, so that's fine. This part is incorrect. So let's go ahead and try this like this and bring this back, because the idea is that it's minus 1, right? We're not going to go out of bounds like that. Okay, cool. So let's submit this again. Okay, we don't need this now. Huh, that's weird. Okay, let's do this. Index out of range. -1, -1. So I plus k. Should we perhaps do it before? Maybe we need to get rid of that there. No. Okay. So I plus k, let's print left and right. Might get output limit exceeded, that's fine. We did it. Okay, so we just need to find that section after it. So after is still 0, and price is I, strategy I, yes, and oh, perhaps it's this. If right plus 1 is less than length of prices, then we can do that. No. Okay. It's just some minor implementation details now. Strategy right, price is right, -1. Okay. So let's think about this. If we're starting with k as 2, 0, 1, 2, then we're just going to start there, and then I plus k is just going to be 0 plus 2, so do we want to subtract 2 or after 2? We want to subtract after 2, so that definitely means that this should be +1. So let's try this. Accept, continue. No? Okay, that's weird. Yeah, we're really close. Just trying to get everything after it. Perhaps we can move this up here. See if that works. No, absolutely not. Okay. If we want from I plus k to the end, why don't we just make a dictionary and put I equals to after. And then we can just say after minus equal to d of I plus k. If I plus k is in d, then we can do this. Okay, that should work. I'm not sure why. That's not right. It's just very strange. Perhaps here we can calculate after again, but then I don't want to comment this out again. So for j in range I plus k to length of strategy, after plus equals to prices j times strategy of j. Yeah, that's always what it is. It's just that minor thing. You know what? Maybe we should subtract it here instead. And then bring this back. Try this. Except after minus equal to 0, so staying the same thing, right? No? Perhaps it's +1, -1. Getting the idea, it's just the implementation is difficult sometimes. So print after, let's print left and right. And if we print P, then we can at least get an idea of what we're looking at. So here, for example, left, right, and after is... Yeah, so there is no after. Yeah, so... if... How about we just do it like that then? Because we're on K. And if I plus K is less than length of prices, then we can just do a... Can't even do a prefix sum. That's weird. Okay, so then we can just do after minus equals to prices I plus K times strategy I plus K. Nope. The biggest pain is always this part. Okay, cool. There we go. So, yeah, if it's less than length of prices, then just subtract it. Yeah, exactly. So let's submit this. Okay, yep, and there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any assistance and solve it completely on my own. So that's it for this video, and thank you for watching.